In this section, we want to talk about the composition of functions, and actually really our main topic of interest will be the decomposition of functions, the last topic in this section, which will be a really critical skill to have moving into calculus in a later semester. We'll start by looking at how we create a composite function. Given two functions, f and g, we can create what we refer to as a composite function and notate as f of g of x, or this different notation, f open circle g of x. We have two different notations here, mean exactly the same thing. We can either read this as f of g of x, meaning we're evaluating the function f at g of x, or we can read it as f composed with x at g, f composed with g at x. I tend to stick with this first definition, or this first phrasing. I think it's a little bit simpler and potentially a little bit more intuitive, but either one works. Let's look at what this means practically. We want to using the two functions given, construct f of g of x and g of f of x. We'll start off with f of g of x, which, keep in mind, is the same thing as f of g of x, which literally means we're going to take the function g of x and plug it into f of x for every iteration of x that we see. So if we let f of x be in green, g of x be in red, that means f of g of x will be 2 times the quantity 5x squared plus 4x, meaning what we've done is substituted in the function g of x for that x that occurs in f of x, plus 5. Then we'll just distribute through or perform whatever operations we have to simplify this expression. This will be 10x squared plus 8x plus 5. To find g of f of x, we'll more or less apply the same approach, but now we'll be taking the function f of x and plugging that into g of x. Meaning we'll take 5 times our expression for f of x, 2x plus 5, that quantity squared, plus 4 times, once again, our expression for f, which is 2x plus 5. The first thing we'll do is expand out 2x plus 5 squared, which means taking that quantity by itself, times itself, to get 4x squared plus 20x plus 25 plus 4 times 2x plus 5, which in this step we haven't changed. Now we'll distribute through and then look at combining like terms. This will give us 20x squared plus 100x plus 125 plus 8x plus 20. And then we have like terms, the two constant terms and the two x terms that we can add together to get a final composite function of 20x squared plus 108x plus 145. Notice that f of g of x and g of f of x are different results. They can turn out to be the same, but in many cases they'll be different from one another. Let's work through one more example of that in part 2 here. We want to find m of n of x and n of m of x. Even though we're using different function names, it's the same idea. If we let m be our green function, n be our red function, then we'll start off with our function m and substitute in n of x everywhere an x occurs. So in place of that first x, we'll get 4x cubed plus 6 plus 3, or 4x cubed plus 9. Finding n of m of x is going to take a little more work. We'll start off with our function n and plug in our function m everywhere x occurs, meaning this will be 4 times x plus 3, that quantity cubed, plus 6. Just like we did in example 1, now we'll expand out and then combine any like terms to simplify. Keep in mind that x plus 3 cubed is the same thing as x plus 3 times x plus 3 times x plus 3. To start off, we'll just multiply the first two binomials together. This will give us x squared plus 6x plus 9 times x plus 3. And now what we need to do is take every term in this first expression times each term in the second expression, meaning we'll take x squared times x to get x cubed. We'll take x squared times 3 to get 3x squared. We'll take 6x times x to get 6x squared, 6x times 3 to get 18x. We'll take 9 times x to get 9x, and 9 times 3 to get 27. Now we'll bring down the pieces that we left behind. This whole expression was getting multiplied by 4, and we were adding 6 to it. As we distribute through the 4, we'll get 4x cubed plus 36x squared plus 108x plus 108 plus 6. Then combining our like terms, which is just the 108 and the 6, we'll get 4x cubed plus 36x squared plus 108x plus 114. So a fair amount of work there with expanding out that cube, but the same idea applies. Whatever function comes second, we take that and we substitute it in to the other function. And then the rest of that is just algebra to expand and simplify.